Number 1. Wheel bearing failure. That is the sound of your wheel bearing announcing its final days. If you've ever heard this low humming or grinding noise that gets progressively louder as you drive faster, you're listening to a wheel bearing dying in real time. This sound is often compared to an airplane taking off, and it intensifies during turns, sometimes even vibrating through your steering wheel. Wheel bearings are steel balls held in a metal race inside your wheel hub. Their job is to reduce friction while supporting the entire weight of your vehicle as wheels spin thousands of times per mile. Each wheel has one, and they endure incredible stress from potholes, lateral forces during cornering, and the constant weight of your car pressing down on them. When they're new, you hear nothing. When they fail, they announce it loudly. The failure process usually starts with compromised seals. These seals keep grease inside and water and road grit outside. Once a seal cracks or tears, grease leaks out and contaminants rush in. The steel balls begin grinding against contaminated races, creating that distinctive growling sound. Here's what makes this dangerous. A completely failed wheel bearing can seize, locking your wheel while you're driving. In extreme cases, the wheel can separate from the vehicle entirely. The repair cost is typically between $150 and $400 per wheel, but if you ignore it long enough to damage the hub assembly or spindle, you're looking at over $2,000 in repairs. There's a clever diagnostic trick mechanics use. The noise changes depending on which way you turn. If the grinding gets louder when turning left, your right bearing is failing. The side you turn away from is where the problem lives, because turning shifts weight onto that bearing. But the next sound we need to talk about doesn't just affect your ride comfort, it threatens your ability to steer altogether. Number 2. The clunking rattle. Loose tie rod ends. If you ever hear this sound coming from your front end, especially during tight turns or overbumps, you need to understand what's happening immediately. That distinct clunking or popping noise, often accompanied by a jolt through your steering wheel, is your tie rod end crying out for attention. Tie rod ends are small ball and socket joints that connect your steering rack directly to your wheels. When you turn your steering wheel, hydraulic or electric power moves the steering rack side to side, and the tie rods transfer that motion to your wheels. Without functioning tie rod ends, you literally cannot steer your vehicle. They're not optional components. They're the final link in the chain between your hands and where your car goes. The ball joint inside the tie rod end sits in a socket, allowing it to pivot smoothly as your suspension moves and your wheels turn. Over time, this ball joint wears down. The socket becomes loose, creating excessive play. Every steering input and every bump in the road accelerates this wear. The clunking you hear is metal moving inside worn sockets with too much clearance. That's the sound of a safety-critical component failing. Complete tie rod failure means that wheel loses its connection to your steering input. One wheel would refuse to respond while the others turn, causing immediate loss of control. Mechanics check tie rods by grabbing the wheel at 9 and 3 o'clock and trying to rock it side to side. Any movement means the tie rod or ball joint has excessive play. You'll also notice your car pulling to one side, steering feeling loose and unresponsive, and unusual tire wear patterns where the edges look feathered or cupped. Speaking of components under stress, there's another sound that starts quietly but escalates into something you can't ignore. Number 3. The alternator, pulley and bearing failure. This is the sound of your electrical system's lifeline slowly dying. When you hear a whining or squealing noise that increases with engine RPM, possibly accompanied by a burning smell, your alternator is sending a distress signal that demands immediate attention. Your alternator converts mechanical energy from your engine into electrical power for everything in your vehicle. Inside the alternator, tiny bearing needles allow the rotor to spin smoothly within the stator, generating electricity through electromagnetic induction. The pulley on the front transfers rotational force from the serpentine belt to the alternator shaft. Modern alternators spin at incredibly high speeds, sometimes exceeding 15,000 RPM, which puts enormous stress on those internal bearings. Bearing failure is the most common culprit. Lack of lubrication or contamination causes friction, heat, and that telltale grinding or whining sound. Many modern alternators use a decoupler pulley, which is a sophisticated one-way clutch mechanism. This clutch allows the alternator to overrun the engine during deceleration. reducing vibration and improving fuel economy. When the decoupler fails, it creates a rattling sound at idle that may disappear at higher RPM, confusing even experienced mechanics. A failed alternator means your battery stops charging. Your car will run on battery power for maybe 30 minutes to an hour before everything shuts down. But here's the bigger problem. When alternator bearings seize completely, the pulley locks up. This shreds your serpentine belt, which also drives your power steering pump, water pump, and air conditioning compressor. Suddenly you lose power steering, your engine starts overheating, and you're stranded. The repair cost for just an alternator runs between $300 and $600, but if you destroy the belt and damage other accessories, that number doubles or triples. While the alternator keeps your electrical system alive, another belt-driven component is equally critical for preventing your engine from self-destructing. Number 4. The water pump squeal. That is the sound of your engine's cooling system failing, and you have minutes, not hours, before serious damage occurs. A squealing, howling, or grinding noise from the front of your engine, especially one that makes you wince every time you start the car, means your water pump bearings are destroying themselves. The water pump is your engine's heart, continuously circulating coolant through the engine block, cylinder heads, radiator, heater core, and all connecting passages. Hot coolant from the engine flows to the radiator where it cools. Then the water pump pushes it back through the engine to absorb more heat. The pump consists of a shaft with a pulley on one end and an impeller on the other, supported by sealed bearings that allow smooth rotation. The serpentine belt drives the pulley, spinning the impeller at several thousand RPM. Bearing wear is the primary killer. Constant operation gradually degrades the bearing surfaces, and once they start making noise, failure is imminent. Improper belt tension can bend the shaft, causing bearings to wear unevenly and fail prematurely. The pump has a mechanical seal, preventing coolant from leaking out the front of the housing. When this seal fails, coolant seeps into the bearings, washing away lubrication and causing rapid destruction. Your water pump has a small weep hole specifically designed to let coolant escape when the seal starts failing. If you see coolant dripping from this hole, your pump is giving you advance warning before the bearings fail. Once the pump stops circulating coolant, your engine overheats catastrophically within minutes. We're talking about warped cylinder heads, cracked engine blocks, blown head gaskets, and damage exceeding $4,000. A water pump replacement costs between $300 and $600 depending on the vehicle. Ignore the noise and you're gambling with your entire engine. From components that prevent engine damage to ones that prevent you from crashing, let's talk about a sound that's actually designed to be annoying. Number 5. The brake pad. Wear metallic screech. This is the sound of engineering genius doing exactly what it was designed to do. That high-pitched squealing or scraping noise, whether it happens when you press the brakes or just while driving, is a deliberately engineered warning system screaming at you to take action. Brake pads have a small metal tab built into them called a squealer or wear indicator. This tab sits just above the friction material. When your brake pad wears down to approximately 2 to 3 millimeters of thickness, the minimum safe level, before you're risking brake failure, this metal tab makes contact with the rotor. The result is an ear-piercing shriek that's impossible to ignore. This isn't a malfunction. The noise is intentional. Your brake pads wear down through normal use. Every time you press the pedal, friction material transfers to the rotor, slowly reducing pad thickness. Heavy braking, mountain driving, stop-and-go traffic, and aggressive driving all accelerate wear. Most brake pads last between 25,000 and 70,000 miles, depending on driving style and pad material. Ceramic pads last longer but cost more. Organic pads are quieter but wear faster. Semi-metallic pads offer good performance but can be noisier. If you ignore the squealer and keep driving, you'll wear through the pad completely. Then it's the metal backing plate grinding directly against your rotor. There's legitimate confusion around brake noise because some squealing is normal. New pads squeal during break-in. Light surface rust from overnight moisture can cause temporary squealing. Cold weather affects pad material. But consistent squealing, especially the kind that doesn't go away after a few stops, means your wear indicators are doing their job. While brakes keep you from hitting things, the next component keeps power flowing to your wheels, and when it fails, the sound is unmistakable. Number 6. The CV joint and driveshaft clicking sound. If you ever hear this sound during turns, especially tight turns in parking lots, your CV joint is in its final stage of life. That sharp clicking or popping sound that matches your wheel rotation means internal damage has already occurred and complete failure is approaching fast. Constant velocity joints, universally called CV joints, are sophisticated ball and socket assemblies that transfer power from your transmission to your wheels while simultaneously allowing suspension movement and steering articulation. Front-wheel drive and all-wheel drive vehicles have CV joints on the front axles. Some rear-wheel drive vehicles with independent rear suspension also use them. Each joint contains 6 steel balls that ride in curved grooves, allowing the axle to operate at various angles without binding. The entire assembly is packed with special CV grease and sealed by thick rubber boots. Boot failure is the #1 cause of CV joint death. These rubber boots crack from age, tear from road debris, or come loose from their clamps. Once the boot tears, centrifugal force flings grease out within days or weeks. Dirt, water, and road grit rush in to replace it. The steel balls begin grinding against contaminated grooves, creating pits and wear patterns. Without lubrication, friction increases and the clicking begins. Lifted vehicles or vehicles with modified suspension can stress CV joints beyond their design angles, accelerating wear. Age-related degradation affects the rubber boots after about 100,000 miles, though tears can happen anytime. The clicking you hear is those steel balls dropping into worn grooves and climbing back out as the joint rotates under load. Turns make it louder because steering increases the operating angle, forcing the balls to work harder. Complete CV joint failure means the axle shaft can separate. Power stops reaching that wheel. Or worse, the wheel locks up unexpectedly. Replacing a CV axle costs between $200 and $400 per side. Ignoring it risks transmission damage, differential damage, or sudden loss of control. Mechanics use a simple test. Put the car in reverse, turn the wheel fully to one side, and back up in a circle. Loud clicking identifies which side is failing. Now, from components that deliver power to ones that start the power delivery process, there's a sound every driver dreads on a cold morning. Number 7. The starter motor failure. This is the sound that means you're not going anywhere until something gets fixed. When you turn your key and hear grinding, gnashing metal teeth chewing on metal teeth, your starter motor is destroying itself and possibly your flywheel along with it. Sometimes it's rapid clicking. Sometimes it's complete silence. None of these outcomes gets your engine running. Your starter motor is a high-torque electric motor with a small gear called a bendix or pinion gear that extends outward when you turn the key. This gear meshes with a much larger ring gear attached to your engine's flywheel or flex plate. The starter spins the engine at roughly 200 RPM, fast enough for the pistons to start compressing air and fuel and for the ignition system to create combustion. Once the engine fires and reaches idle speed around 600 to 800 RPM, the starter disengages. The Bendix gear teeth wear down over time, especially if you frequently crank the engine for extended periods. If teeth break or wear into rounded nubs, they can't properly mesh with the flywheel gear. The flywheel ring gear can also suffer damage. This is catastrophic because fixing it requires removing the transmission to access the flywheel, turning a $300 starter replacement into a $1,500 transmission removal job. The solenoid, which pushes the Bendix gear forward to engage the flywheel, can fail electrically or mechanically. Loose mounting bolts cause misalignment between the starter and flywheel. Some starters require precise shimming during installation to achieve proper gear mesh. Every time you hear grinding and continue cranking, you're making the damage exponentially worse. Stop immediately. If you've ever accidentally tried starting a car that's already running, that horrible grinding is exactly what a bad starter sounds like. The flywheel spinning faster than the starter can handle creates violent overspinning of the gear. While the starter gets your engine running, the final sound we need to discuss comes from deep inside the engine itself. Number 8. The piston slap. That is the sound of pistons rocking inside cylinders with more clearance than the engineers intended. If you hear a rhythmic knocking or slapping sound that matches engine RPM, Loudest during cold starts and often disappearing as the engine warms up, you're hearing piston slap. Pistons are thick aluminum discs connected to the crankshaft through connecting rods. They slide up and down thousands of times per minute inside precision-machined cylinders. Engineers design specific clearances between pistons and cylinder walls. Too tight and friction increases, causing overheating and seizure. Too loose and pistons rock side to side, slapping against cylinder walls. Aluminum expands when heated, so cold pistons have more clearance than warm ones. This is normal by design. Piston wear gradually reduces the diameter of the piston skirt, the cylindrical section below the piston rings. Cylinder wall wear increases bore diameter. Both processes increase clearance. High-mileage engines naturally develop more clearance. Modern engines use lightweight short-skirt pistons to reduce reciprocating mass and improve fuel economy. These designs are more prone to rocking. When cold aluminum pistons sit in relatively warmer cylinders, the clearance is at its maximum. As the engine runs, pistons heat up and expand, reducing clearance and quieting the noise. Here's the surprising reality. Piston slap is often not an emergency. Many engines run for years with piston slap without catastrophic failure. It's primarily an annoyance related to noise and vibration. Severe cases can lead to increased oil consumption as rings lose sealing effectiveness and eventual piston skirt cracking. But this takes considerable time. The temperature test distinguishes piston slap from more serious problems. True piston slap gets quieter or disappears as the engine reaches operating temperature. Rod bearing knock, which indicates imminent engine failure, gets worse when warm and under load. If the knock persists or worsens after warm-up, you're dealing with bearing failure, not piston slap. Oil analysis can also reveal excessive bearing material in the oil, confirming the worst. So, what sounds have you heard coming from your car? Have any of these noises been trying to get your attention? Drop a comment below and let us know. If this video helped you identify a problem before it became expensive, smash that like button and subscribe for more automotive insights that could save you thousands. Until next time, drive safe and listen to what your car is telling you.